Let's go ahead and check out two more on the next page. So same directions, we're going to go ahead and first see if the intermediate value theorem does apply, and if it does, we're going to go ahead and try to figure out that special spot within the interval that would have the specific output that we're looking for. So for this first function, we got to check continuity. It's a fraction, so we have to be careful about the denominator. And notice how at the x value of 2, we would be undefined, specifically a vertical asymptote, because we get 2 over 0. But if we take a look at the interval, notice how 2 is not within the interval or the specific region that we are focusing on. So even though it is discontinuous at 2, it's not in the interval, so it's not a problem anymore. So we can say f of x is continuous on the interval because the vertical asymptote of x equals 2 is not within the interval. So it meets the first criteria that we need to check. The second criteria is that the output we are specifically wanting, in this case -1/2, is between the outputs from the interval. So we have to plug in interval value of -1, and we'll see what we get. We get -1 over -3, which would be a 1/3. And then if we plug in the other interval value of 1, we'll get 1 over -1, which is -1. And if we take a look, -1/2 is between our outputs. So -1/2 is between 1/3 and -1. So the intermediate value theorem does apply. We should have some x value between -1 and +1 that has an output or an answer of -1/2. So we're actually going to go ahead and find it. So if this -1/2 is an output, that's representing a specific answer that we want from this equation. So we'll set the equation equal to that -1/2, and we got to ask ourselves, how do we want to solve from there? If you have two fractions equal to each other, we can cross multiply to get rid of those fractions. So x times 2 would be 2x, and then -1 times x minus 2 would switch all the signs, and we would have -x plus 2. So solving from there, we can add the x over and then divide by 3. So it looks like our x location is 2/3. That's clearly between -1 and +1, just like the intermediate value theorem said it should be. Let's go ahead and check out 5. So checking continuity, notice the type of equation we have is an exponential function, and it does have some flips in there, so it could be growth or decay. We'd have to analyze it a little bit further. But every exponential function basically has a shape that's growth or decay, something like that. And if you analyze continuity, every single exponential function is continuous. So f of x is continuous on the interval. There's no holes, no jumps, no asymptotes on an exponential graph. Let's go ahead and check out the second criteria. We got to make sure -4 is in between the outputs from the interval. So if we were to go ahead and plug in 3, notice how our exponent would be 0. 1/2 to the 0 power is 1. We have a negative out front, which would change it to -1, and then -2 would give us a -3. If we go ahead and plug in 5, -5 plus 3 is -2. The negative power can flip the base, so the base would now become 2. And we still have a power of 2, so 2 squared would be 4. The negative out front would make it -4, minus 2 would make it -6. So our outputs are -3 and -6. Notice how the output we want of -4 is between those. So -4 is between -3 and -6. So the intermediate value theorem applies. That means there should be some x value between 3 and 5 that would give us an answer or an output of -4. So let's go ahead and see if we can actually figure out that special x location. So we'll set the function equal to the output of negative 4. Solving for x, we can add over the 2. We can divide the negative. And this is when it gets good. All right, so in order for us to solve for x, notice how x is kind of trapped in that power position. We have to move the base of 1/2 to the other side. And from your pre-calc studies, if you want to move a base over to the other side, it has to become a log with that same base. So we would have log base of 1/2 of 2. So we got to ask ourselves, what power do we have to raise 1/2 to in order to get an answer of 2? Now that power would be negative 1, because notice how we would have to flip this 1/2 to make it a 2. So in order to flip a base, you'd have to have a negative power. So solving for x, we can subtract the 3 and then move the negative. Notice how our x solution would be 4, and that's clearly within the interval that we had at the top between 3 and 5.